In part 2 of document 7, the immunological memory, we are going to explain how can the immunological memory be acquired. The immunity and therefore the immunological memory can be acquired in two ways. A passive way called the passive immunity, which is the transfer of antibodies from one individual to another. It's the transfer of ready-made antibodies. And the active way called the active immunity, which is the stimulation of the individual's immune system by contact with the antigen. The passive immunity can be natural from mother to fetus through the placenta, which is a barrier that separates the maternal blood and the fetal blood, but it allows the passage of antibodies produced by the mother during her life to her fetus. Also, the maternal milk contains antibodies that can be transferred to the fetus. So in this case, this is not the fetus who produces the antibodies, but the mother produces the antibodies following the infection with pathogens she may encounter during her life. Then the mother transfers these antibodies to her fetus during pregnancy via placenta or after birth via the maternal milk. Also, the passive immunity, which is the transfer of antibodies, can be artificial. And it's the case of serotherapy. Therapy with the serum. Therapy to treat patients using serum containing antibodies from another patient. So we have ready-made antibodies produced by an animal that has been injected with an antigen or produced by an individual and transferred to another individual in order to confer or to give this individual an immunity against this antigen. When we talk about active immunity, it can also be natural due to the infections during life. When we are infected with pathogens, our immune system becomes active, produces specific lymphocytes that differentiate and that eliminate the intruders and that give memory cells. So this process is called active immunity when our immune system is stimulated by the contact with an antigen. The active immunity can be also artificial. It's the case of vaccination, vaccines. It's the introduction of antigens into the body in order to trigger immune responses without causing the disease. In this case, the individual is immunized against one or more diseases depending on the nature of the vaccine. Thus, these are the two ways by which the immunological memory is acquired. Concerning the passive immunity, we are going to talk about serotherapy. Example, the case of tetanus. Tetanus is an acute infectious disease characterized by intense, extremely painful muscle contractions. And it is caused by a bacterium called Clostridium tetani, which enters the body through a contaminated wound. The contractions are due to the action of a toxin called tetanus toxin secreted by Clostridium tetani, and this toxin has severe effects on the nerve centers. So, in a person who may have been contaminated by an injury and not vaccinated against tetanus toxin, the doctor injects anti-tetanus serum. Why does the doctor inject anti-tetanus serum? Because The injection of the serum containing specific anti-tetanus toxin antibodies will allow the formation of immune complexes, and these immune complexes will neutralize the tetanus toxin and lead to its elimination through phagocytosis by phagocytes or through the activation of the complement. Therefore, the toxin will not reach the nerve centers and cause the symptoms. But these ready-made antibodies found in the serum injected to this person are quickly eliminated. They are not durable, they don't persist. But the serotherapy is a rapid therapy to confer a rapid immunity and to prevent the propagation of the infection. In order to confer a long lasting immunity or memory, this serotherapy should be coupled with a vaccination with the injection of the tetanus toxin and not the antibodies anti-tetanus. So the doctor injects anti-tetanus serum coupled with the tetanus toxoid. Tetanus toxoid is the attenuated tetanus toxin which has lost its pathogenic power but which has kept its immunizing properties or antigenic epitopes. Thus, the joint injection of tetanus toxoid and the anti-tetanus antibodies stimulates the immune system of this person, which will set up an immune response characterized by the increase in the level of antibodies produced, since we activate in this way the B lymphocytes to differentiate into plasma cell secreting antibodies. So the level of antibodies is much higher than the level of antibodies found in the serum, and this response is more effective, ensuring a level of antibodies necessary for the protection. Then we can make a second booster, a second injection of tetanus toxoid at 20 weeks further, which increases the response times 30. As you can see, this graph shows the evolution of the levels of plasma antibodies in the case of the vaccination against tetanus. The first vaccine injected on the first month results in a weak response, small amount of antibodies secreted, and requires thus boosters to be effective in the long term. So that's why we have many vaccine injection called recalls. So the recalls are spaced 5 to 10 years apart, indicating the long life of the memory cells produced after each vaccine or each recall. So the recalls boost our immune system and give a long-lasting memory or immunological memory. What is the principle of vaccination? Antigens are introduced into the body in an attenuated form in order to trigger an immune response without causing the disease. So the purpose of vaccination is to mimic the natural infections and to exert a preventive action and give the body immunity. The types of vaccines. The vaccines are made from either live but attenuated microorganism or dead or killed microorganism killed by high temperatures. Also, vaccines are made from neutralized or attenuated toxins. They can be made from also isolated antigens produced by genetic engineering by transgenesis. Now, passing to the evolution of the immunological phenotype. Throughout his life, an individual is subjected to a multitude of infectious agents. As you can see here, this individual, this man, has encountered antigen 1, then antigen 2 during his life, then he was vaccinated against antigen A, for example. So he has a repertoire, a variety of lymphocytes that or evolve during his life. For this woman, she has encountered antigen X, for example, not antigen 1 nor antigen 2. She has encountered antigen Y. She has been vaccinated against antigen B. So she has a different group of lymphocytes. Hmm? You can see different groups of lymphocytes. So this difference is called the immunological phenotype, which evolves over the life depending on the infections and the vaccinations. To conclude, by allowing the formation of memory cells, the natural or artificial encounter, vaccination, with infectious agents confers protection against them. And this protection is observed at the level of the individual and at the level of the whole population. It is observed at the level of the reduction in the incidence of a disease following vaccination. Several diseases are eradicated and have become rare in countries where vaccination programs are well implemented. This reflects the adaptation of the immunological phenotype to the environment. Thank you.